If you were to gather all the primates that walk the earth and line them up by physical strength, the top spot wouldn't go to a chimpanzee, an orangutan, or even a human. It would go to a gorilla. And not just by a small margin, the gap would be so significant that the second place would have no business being nearby. This is where things get interesting, because while most people know this fact, very few understand why it is so. When I say the top spot, I'm not referring to some arbitrary internet ranking, but to real measurements taken in laboratories and field conditions. It's all about the muscles, but it's not about their size, as one might think. It's about their type. Before we continue, please let us know in the comments where you're watching from and subscribe to the channel. Gorillas predominantly have what scientists refer to as fast-twitch muscle fibers, specifically type 2B. These fibers operate on the principle of short, powerful bursts. They can exert tremendous force in a fraction of a second but tire quickly. That's why a gorilla won't run a marathon or chase prey over long distances. However, in a moment of acceleration, it exerts such effort that it seems almost unreal for its body mass. In comparison, humans have a much lower percentage of these fibers. Our bodies are built for endurance, for prolonged activity under moderate load. We can walk for hours, run long distances, but we pay for that with explosive power. The gorilla made the opposite choice. Now, it's important to make one significant comparison here. A horse weighs about 5 to 6 times more than a gorilla. A grizzly bear is also significantly heavier. In terms of absolute pulling power, the gorilla falls short, which makes sense because mass is mass. But if you take strength and divide it by body weight, the gorilla comes out on top. It's like if an athlete in the under 80 kilogram weight class lifted as much as a super heavyweight. It sounds impossible, but in the primate world, it's a reality. Now let's talk about how a gorilla walks. Everyone has seen that characteristic gait on its knuckles, where the animal supports itself not on its palms, but on the bent fingers of its front limbs. From the outside, it looks clumsy, and many automatically think it's something primitive, an intermediate stage between a four-legged animal and a bipedal human. But in reality, it's quite the opposite. Walking on knuckles is a highly precise biomechanical adaptation. Gorillas have heavy torsos, massive chests, and powerful shoulders. If they walked on flat palms, the load on their spines would be distributed differently, and their wrists would experience too much pressure. Knuckles allow them to transfer weight to a sturdier part of the hand while keeping the spine in a relatively comfortable position. This isn't an evolutionary oversight, it's an engineering solution that has worked for millions of years. Interestingly, chimpanzees also walk on their knuckles, but the mechanics are slightly different because their body proportions vary. Gorillas have perfected this adaptation precisely because they have to carry more weight than any other primate on the planet. Another fascinating aspect is the skull. If you look at the head of an adult male gorilla from above, you'll notice a bony ridge running along the top from the forehead to the back of the head. This is called the sagittal crest, and it looks as if someone glued a small ridge to the skull. What's it for? The chewing muscles attached to this crest. Not the small muscles that help us chew a sandwich, but enormous muscles that generate enough pressure to grind tough plant material, tree bark, fibrous stems, hard roots. Gorillas eat what most other animals wouldn't even consider, and for that, they need a jaw that works like an industrial press. And an industrial press needs something to anchor to, and the sagittal crest provides that platform. Now here's a fact that few people know, even among those interested in biology. Gorillas have only one blood type, type B. Humans have 4, A, B, AB, and O. Chimpanzees also have variations, but gorillas have only B, without exception. This isn't a trivial detail or a quirk. It's a significant marker of evolutionary divergence. Blood type is determined by antigens on the surface of red blood cells, and the fact that an entire species has preserved only one variant indicates how long and how far their evolutionary path has diverged from ours. Millions of years ago, our common ancestor likely had more variants, but the gorilla lost all but one during evolution. Why type B remained while the others disappeared is still an unanswered question, but the fact itself makes the gorilla unique even among its closest relatives. There's another thing that makes you think. Gorillas in captivity, especially adult males, disproportionately suffer from cardiomyopathy, a disease where the heart muscle weakens and fails to pump blood effectively. This condition is significantly rarer in females in the same zoos. Scientists have long tried to understand the cause, and the current theory is that it's related to stress. A male gorilla in the wild controls territory, makes decisions, moves, and interacts with dozens of environmental factors every day. In an enclosure, there's nowhere to go, nothing to decide, and all that energy that should be spent on life impacts the one organ that can't stop, the heart. This sounds almost metaphorical, but it's a medical fact, supported by autopsies and cardiological studies. And this raises an uncomfortable question. If we know that limited space destroys a gorilla's heart, then every zoo housing an adult male is essentially conducting an experiment with a known outcome. This doesn't mean zoos are useless. Many are genuinely involved in species conservation, but the cost paid by the individual animal is quite specific and can be measured in years of life. Lastly, there's a detail that's both surprising and oddly familiar. Gorillas have fingerprints, real, unique ones, just like humans. In theory, every gorilla on the planet could be identified by its papillary pattern, just as police identify people. But in practice, researchers in the field don't use this method, and the reason is almost comically mundane. To take a fingerprint, you need to hold the gorilla's hand, which, to put it mildly, isn't easy. So, primatologists use a different method. They photograph the nose. Each gorilla has a unique pattern of folds and wrinkles on its nose, which can be seen from a distance through binoculars or a telephoto lens. It's like a passport photo, but instead of a full face, it's a nose portrait. This is how the body of a creature that shares over 98% of its genetic code with us is structured. The same fingerprints, a similar heart that also breaks under stress, muscles built on the same principles as ours, just with different settings. Yet at the same time, there's only one blood type, a crest on the skull, and a knuckle-walking gait. Close and far away at the same time, all in the same body. Here's a paradox worth pondering. An animal capable of bending a steel rod with its bare hands, one that can lift weights 10 times its own, which can break young trees the thickness of an adult's arm with a single motion. This animal feeds on grass, leaves, and roots. No meat, no hunting, no chasing prey. The strongest terrestrial primate on the planet is a vegetarian, and this isn't a choice. It's the result of millions of years of evolution that built a body of incredible power on fuel that most of us wouldn't even consider putting on our plates. And this immediately raises the question that everyone asks when they hear this for the first time. How? How can one build such mass and maintain such strength while eating something that doesn't even come close to the caloric content of oatmeal? The answer lies in quantity. The fiber that forms the basis of a gorilla's diet contains very little accessible energy. One leaf or one stem provides almost nothing. So, a gorilla eats a lot, really a lot. An adult male consumes about 18 kilograms of plant matter a day, and in some observations this number has reached 25. It's like eating 2 large bags of salad every day and still not having enough calories for a run. But volume is only half the solution. The other half is hidden inside, in the intestines. A gorilla's digestive system operates more like a cow's than a human's. In the large intestine, colonies of bacteria break down cellulose, the tough fiber that makes up the walls of plant cells. The human intestine can't handle cellulose at all. It passes through us undigested. But gorilla bacteria break it down into parts and convert it into fatty acids that the body can use as fuel. This process is called fermentation, and it explains one thing that confuses many. A gorilla's belly is always large and round, even if there's no visible fat on its body. This isn't fat or overeating. It's a massive intestine filled with plant matter that's currently fermenting and turning into energy. There's another problem that's rarely discussed: salt. Plant food contains almost no sodium, and sodium is necessary for any organism to function properly. In some regions of Africa, there are natural salt licks, and gorillas visit them specifically to lick the salty earth. But in areas without salt licks, gorillas have found another solution. They eat rotten wood. Decaying wood accumulates minerals from the soil, and somehow gorillas know this. Not because they read a biochemistry textbook, but because over thousands of generations, those individuals that found sources of sodium survived better than those that didn't. This knowledge isn't stored in their heads, it's in their behavior, passed down from mother to offspring. Now, knowing all this about digestion, you can understand one thing that looks like laziness from the outside. A gorilla spends a significant part of the day at rest. It eats, then lies down. Then it eats again, then lies down again. It moves short distances, finds a new patch of food, eats, and lies down. From the outside, it seems like the animal is just lazy and doesn't need anything. But this isn't laziness, it's physiology. Processing 18 to 20 kilograms of coarse plant matter requires a tremendous amount of energy. The intestines are constantly working, bacteria are fermenting without pause, and the body spends calories to digest what will eventually provide calories. If a gorilla starts to move actively, run, or climb trees all day, it will go into an energy deficit. Rest isn't the absence of activity. It's a part of the digestive process without which the entire system would collapse. Now let's talk about something that's discussed even less than nutrition: subspecies. When people say gorilla, they usually mean one specific animal, as if gorillas are a single, uniform entity. But in reality, there are 4 subspecies, and they differ from each other so much that each has its own story, territory, and fate. The western lowland gorilla is the one you've probably seen in a zoo or a documentary. This subspecies lives in captivity, is filmed most often, and that's why most of our knowledge about gorillas is based on observations of western lowland gorillas. They inhabit the lowland tropical forests of West Africa, and there are more of them than any other subspecies. But more is a relative term here, as even their numbers are declining. The cross-river gorilla is a ghost subspecies. Science knows the least about it, not because researchers aren't interested, but because these animals are so cautious and so afraid of humans that seeing them in the wild is nearly impossible. Researchers have spent years, literally years, studying cross-river gorillas without ever seeing a live individual. They've worked from tracks on the ground, feces, and photos from camera traps set up along animal trails. It's like studying a person by their shadow. There's information, but it's always incomplete, and every new fact is obtained with incredible difficulty. According to the latest estimates, fewer than 300 remain. The Grauer's gorilla, also known as the eastern lowland gorilla, is the largest of all subspecies. An adult male can weigh over 200 kilograms, but size hasn't saved this subspecies from disaster, and the reason isn't hunting per se. In the 90s, armed conflicts erupted in the Democratic Republic of the Congo that lasted for years. The war destroyed not only villages and roads, but also all conservation structures. Rangers who patrolled national parks were killed or fled. The boundaries of parks ceased to exist. Armed groups invaded protected areas, logging forests and extracting resources, leaving gorillas in a zone where there was simply no one to protect them. The population collapsed, not because someone was deliberately hunting gorillas, but because the very system that stood between them and destruction disappeared. Finally, there's the mountain gorilla. This is the only subspecies whose numbers are currently increasing, the only one of the four. And the reason for this growth isn't some biological miracle or that mountain gorillas breed faster than the others. The reason is money. Ecotourism in Rwanda and Uganda has created a situation where a living gorilla is worth more than a dead one. Tourists pay hundreds of dollars for the privilege of spending 1 hour near a group of mountain gorillas in their natural habitat. This money goes to national parks, ranger salaries, and local communities. And local residents, who once viewed gorillas as a nuisance or a source of meat, now see them as a source of income that only works while the animal is alive. This isn't romance or charity, it's an economic mechanism, and it works. The mountain gorilla is now living proof that conservation works when it has a financial foundation. What keeps a group of gorillas together? Not herd instinct, not fear of predators, not a territory with food that's easier to defend as a crowd. The answer is simpler yet more complex. Specific relationships between specific individuals. A gorilla knows each member of its group personally, remembers the history of interactions with them, and its behavior toward each is based on that memory. This isn't a herd moving as a single mass. It's a community where each has its own place, connections, and role. At the center of this community is the silverback male. He's called silverback because of the gray fur on his back that appears with age, usually after 12 to 13 years. It's important to remove from your mind the image that imagination typically conjures. A huge male who intimidates everyone and rules by force. In reality, the silverback functions not as a tyrant, but as an arbiter. His main role within the group is to resolve conflicts. When two females argue over a resting spot or food, the silverback intervenes and separates them. When a young male starts to behave too aggressively, the silverback puts him in his place, often without physical contact. Just a look, a posture, sometimes a short sound. Researchers have noticed in long-term observations that when a silverback dies from illness or old age, the group often disbands. Not immediately, not in one day, but over weeks or months, females start to leave, young males scatter, and the structure that held together for years ceases to exist. Because no one can take on the role of arbiter. Young males don't yet have enough authority, and females don't fulfill this role at all. A group of gorillas isn't just a collection of animals living nearby. It's a system that works as long as there's a central element, and it breaks when that element disappears. An additional topic is the memory of females. Researchers who have followed the same populations for decades have documented something remarkable. A female gorilla remembers her relatives even after years of separation. If two sisters end up in different groups and then accidentally meet after 5, 7, or even 10 years, their behavior toward each other differs from their behavior with unfamiliar females. They approach each other more closely, spend more time together, and show less wariness. This isn't instinct or coincidence. It's individual memory that is retained for years and influences social decisions. For an animal that many still consider just a large ape, this speaks to a level of cognitive ability that challenges the very notion of primate intelligence. Now let's talk about communication, and this is where it gets truly breathtaking. The chest thump. Everyone has seen this in movies. Everyone knows this gesture. A gorilla stands up, opens its arms, and thumps its chest with open palms. From the outside, it looks like pure aggression, a display of rage. But a study conducted by researchers from the Max Planck Institute showed that the chest thump is less of a threat and more of an informational message. They measured the acoustic characteristics of the thumps from different males and found a direct correlation between body size and sound frequency. The larger the male, the lower the sound produced by his thumps. This works like a vocal business card. A rival, standing at a distance behind trees or in thick underbrush where nothing is visible, hears the thumps and, based on their sound, determines how big the one producing them is. If the sound is low and deep, then it's likely a large male, and approaching might not be wise. If the sound is higher, it might be worth a try. Conflict is resolved before the two males even see each other. Sound replaces fighting, and this is incredibly effective from a survival standpoint because any real confrontation between two male gorillas carries a risk of serious injury for both. But the chest thump is just the most noticeable element of their sound palette. In daily life, gorillas use a whole range of sounds, each of which means something specific. There's the so-called belch, a low, guttural sound that males produce regularly throughout the day. It's a safety signal, something like a constant radio beacon that tells the group, "Everything's calm, I'm here, there's no threat." There's the feeding hum, a soft, purring sound that gorillas make when they find particularly good food. This isn't just an expression of pleasure, it's a collective reaction that informs others that it's worth stopping here to eat. And there are quiet grunts heard when the group moves through dense forest, where neighbors can't be seen behind the wall of leaves. These are contact signals, a way to maintain communication without seeing each other, something like a roll call, just without words. And since we're discussing how gorillas know more than they seem to, here's a fact that was published very recently, in 2024. A group of researchers in Gabon observed gorillas intentionally eating the bark of certain trees, not just chewing on everything, but selecting specific species. When the scientists checked, they found that this same bark is traditionally used by the local Mwangu people in medicine for stomach and intestinal issues. Coincidence? Laboratory analysis showed otherwise. The substances in this bark have antibacterial properties, even effective against resistant strains of E. coli, the very ones that some modern antibiotics can't handle. A gorilla doesn't know the word antibiotic, but it knows which bark to eat when its stomach hurts. This is self-medication, documented not by journalists, but by biologists, with laboratory data and peer-reviewed publications. And to conclude this part, we can't overlook Coco, the gorilla who learned sign language and became perhaps the most famous ape in history. There's a lot of debate surrounding Coco, and it's important to be honest. Some of what has been attributed to Coco raises justified skepticism among linguists. Critics argue that her caretaker, Francine Patterson, interpreted Coco's gestures too freely, seeing meaning where there might have been coincidence, and that the conditions of the experiments didn't always meet strict scientific standards. These are fair points that shouldn't be ignored. But even the harshest critics acknowledge one thing: Coco changed how millions of people think about gorillas. Before Coco, a gorilla in the public consciousness was something between King Kong and a zoo exhibit. After Coco, people began to see gorillas as beings with whom they could connect, who experience emotions, who can grieve, rejoice, and form attachments. Did Coco understand language the way a human does? Probably not. But did she do more for the conservation of her species than any law or scientific program? Quite possibly, yes. 98.3%. That's how much genetic code gorillas and humans share. This figure is often cited as a fun fact, a reason for jokes about relatives, an illustration for a school biology lesson. But this number has a very practical and rather grim implication that few consider. If two biological systems overlap by almost 99%, it means they are vulnerable to the same things. Gorillas suffer from the same diseases as humans. Not similar diseases, not analogous ones, exactly the same. Influenza, pneumonia, intestinal infections, skin parasites. A virus that would mean 3 days of a runny nose and a sore throat for an adult tourist could be fatal for a gorilla because its immune system has never encountered that specific strain. That's why the 7-meter rule exists, not just for show. When tourists are allowed near mountain gorillas in Rwanda or Uganda, they're told, don't get closer than 7 meters. Don't touch. Don't cough in their direction. If you feel unwell, don't go on the tour at all. This isn't just the guides being overly cautious or caring about the animal's comfort. It's a quarantine measure because one sneezing tourist could theoretically trigger an epidemic in a group of 15 to 20 gorillas, and none of them would have the slightest immunity to that virus. And since we're talking about diseases, here's a story you need to know. The Ebola virus. Most people remember Ebola outbreaks as a human tragedy, and that's correct. But few know that for gorillas, Ebola was a disaster of even greater magnitude when proportionally assessed. At certain times, the virus killed more gorillas than all poachers combined. Moreover, gorillas are not carriers of this virus. They don't spread it and don't live in equilibrium with it. They are victims, just like humans. Infection likely occurs through contact with bats or their droppings on fruit, and after infection, a gorilla dies at the same rate as a human within a few days. Entire groups have gone extinct completely in a single outbreak, without a single shot fired and without a poacher in sight. The virus acted where a human with a gun would never reach, deep in the forest, and did so with an efficiency that surpassed any hunting. Now, let's talk about what's in your pocket right now while you're watching this video. Your smartphone has a processor, and in that processor, there's a metal called coltan. More specifically, tantalum is extracted from coltan, which is used in capacitors, the tiny components without which no modern phone would work. Coltan is mined in several places around the world, and one of the main deposits is located in the Democratic Republic of the Congo, in an area that overlaps with the habitats of Grauer's gorillas and mountain gorillas. The mining of coltan in this region has long financed armed groups that controlled the mines and used the profits to buy weapons and continue military actions. Alongside mining, deforestation occurred because cleared land is needed for mines, roads, and worker camps. This isn't a conspiracy theory or an exaggeration from environmentalists. The connection between coltan mining, armed conflicts, and the destruction of gorilla habitats has been traced and documented by journalists and researchers with specific names, dates, and coordinates. Now, it's worth pausing to discuss what gorillas are worth to the forests they inhabit. Not in monetary terms, but in ecological ones. Gorillas are engineers of their ecosystem, and this isn't a pretty metaphor, it's a description of a specific biological mechanism. When a gorilla eats fruit, the seeds pass through its digestive tract and exit hundreds of meters, sometimes even kilometers, away from where the fruit was picked. Moreover, the seeds of certain trees in the Central African forest germinate significantly better after passing through the intestines of a large primate. The acidic environment of the stomach softens the seed coat, giving it an advantage in germination that it wouldn't have had if it simply fell to the ground under the parent tree. Remove the gorilla from this equation, and those trees will start to disappear. Not tomorrow, not in a year, but over decades, the forest will change because some of its species will lose their main means of dispersal. And when the forest changes, everything living in it changes. Birds, insects, small mammals, understory plants. Gorillas don't just live in the forest, they build it. And if this builder disappears, the forest will stand for a long time. But with each passing decade, it will become different, poorer, and simpler, and at some point, it will become irreversibly altered. Now, knowing all this about muscles, digestion, social connections, diseases, coltan, and tree seeds, you can say what all this leads to, and it won't be a conclusion or a moral, just an observation. A creature whose physical strength has no equal among terrestrial primates has over millions of years of evolution built a system where this strength is almost never used directly. A male gorilla doesn't fight for territory every day. He thumps his chest, and the sound resolves the conflict before it escalates to contact. The silverback doesn't lead the group through fear. He mediates disputes and maintains balance. Females remember relatives after years of separation and build relationships based on that memory. The group functions not because someone forces them to, but because everyone knows their place and trusts the one at the center. Demonstration is proven to be more effective than fighting. Not in some philosophical sense, not as a pretty idea from a self-help book, but as a real survival strategy that has passed the test of natural selection. Those males who resolved conflicts without fighting sustained fewer injuries and lived longer. Groups with a strong arbiter maintained stability and raised more offspring. Individuals who remembered relatives and maintained connections had a better chance of receiving help in tough times. All of this isn't a moral or a fable. It's a documented evolutionary strategy tested over a time span that the human mind can hardly comprehend. And finally, gorillas don't know that we're making videos about them. They don't know that we're debating their intelligence, counting their populations, or trying to save their forests. They simply live, eating their 18 kilograms of leaves a day, tucking their young into nests made of branches, thumping their chests when someone gets too close, and falling asleep at sunset. The only question is whether there will be a place for them to do this. And the answer to that question doesn't depend on them.